Now this is a question where you need to predict the shape of the molecules depending upon the VSEPR theory, right. So we have ClF3 molecule, we have BrF5, we have NH2 negative, we have hydronium ion, H3O positive. So the formula to predict the shape is that you need to find like if you want to know the shape actually, or you want to know the total electron pair present, what you need to do is half plus valence electron plus number of surrounding atoms. This you need to do, right. And electron pair, this is the total electron pair. Now if you want to know the bond pair out of the electron pair, it will something equal to the number of surrounding atom. And if you want to know the lone pair, so obviously you need to minus the electron pair, bond pair from the electron pair, and after doing that you will get a combination, right. So this is what I am going to apply here. So this is my ClF3. So that means in this case, first I need to find total number of electron pairs. So for this I have half into Cl has valence electron 7, we all know, surrounding atom is 3. So what do we get? Half into 10. So that means total electron pair present is something 5. Now we want to know that how many is the bond pair. So the you can say the surrounding atoms indicate the bond pair. So how many surrounding atom? You can see 3. So 5 minus 3, sorry. So that means the bond pair is 3, and lone pair is total electron, well, this thing bond pair minus total electron pair. So 5 minus 3 comes out to be 2. So that means I am going to possess a structure where I will have a central atom, bond pair is 3 and lone pair is 2. So this is my geometry actually. So by just knowing this, now I want to know that like by just looking at this, we got to know there is one central atom and 5 surrounding atoms, out of which 3 are the bond pairs and 2 are the lone pairs. So obviously we know that how to arrange it. So 2 lone pairs, we know that we arrange in this manner. So this is what trigonal pyramidal is going to be the geometry of ClF3. Likewise, I have for BrF5. So again I am going to do that. Valence electron for bromine is 7, surrounding atom is 5, comes out to be half into 12, comes out to be 6. So I have AB6. Now I am going to find out that out of these surrounding atom, how many are the lone pair and how many are the bond pair. So that means my bond pair is just equal to the number of surrounding atoms, that is 5. And lone pair, we know that we can just subtract it from this and we get the lone pair. So the formula becomes A, B5 and L, right. So that means it is distorted octahedral, So now when I am going to put it, I am going to put it in such a manner that this occupies the lone pair. And what is the name for the geometry? Obviously it is going to be square pyramidal. So likewise, now I have the NH2 negative. So what you get to see here in NH2 negative, so again I am going to imply a same formula, that is half into valence electron of nitrogen, that is 5, surrounding atoms 2 hydrogens, 2, and what you can see here is one negative sign. So if you get to see one negative sign, you need to add that much, and if you get to see you can say plus charge, you need to subtract that is vice versa, right. So here what you see that here is one negative charge, so you need to add one electron. So this is what I am doing is, I have this, I am going to add 1. So what do I get after that? I get 6, 7, 8. So my total electron pair comes out to be 4. So now if I talk about the electron pair, so obviously it is going bond pair, it is going to be equal to the surrounding atoms. So that means I have like it was AB4, but because we need to find the lone pair also, so it becomes A, B is 2, bond pair 2, and how many lone pairs? Obviously 4 minus 2, because total electron pair minus the bond pair, we get that. So it becomes out to be AB2, L2. That means it is distorted tetrahedral, like we did for that. This is NH2 negative, so obviously it is going to be this thing, and this will be a lone pair. So this is what you are going to do or find the geometry in this case. We are left with one more, that is H3O positive. So again half into valence electron, it is the O. that means that is 6 plus surrounding atoms 3. You need to you saw that one positive, that means you need to subtract 1, right. So that means it comes out to be half into 8. 6 plus 3 9, 9 minus 1 8. So it comes out to be 4. Now how many bond pairs? Obviously 3, right. So it is AB 3. And how many lone pairs? 4 minus 3 L. So obviously it is again a distorted tetrahedral, but it has one lone pair, so that means it is going to possess a pyramidal geometry. So likewise you will get a question, you just need to remember that first you need to find the total electron pairs. You need to find total electron pairs by putting this formula, half into valence electron plus number of surrounding atoms. Once you get that, just look at that how many surrounding atoms are there. So number of surrounding atoms just confirms the bond pair. I repeat, number of surrounding atoms just confirms the bond pair. And after that what you need to do is, you need to subtract the bond pair from the bond pair from the electron pair, and after doing that you will get a result of lone pair. Just try to write in AB form, ABL form, put it this, like this will be a central atom, put B as 2, 3, 4, whatever comes, like whatever is the number for the bond pair, and likewise whatever number is for the lone pair. Then total it, then you will get a perfect geometry, that was the original one. Then just try to remember that where, like if it possesses 1 or 2 lone pair, at what position you are going to put those lone pair. And after just doing that, you will be familiar with the geometries, and it is not a big deal. Once you look for the formula, you will put the formula, you will easily come to you can say draw a geometry or to know a shape of the molecules. So this is what actually VSEPR theory actually want to explain you. And the other thing is that you must be thinking that like we studied the Lewis theory, now we are studying the VSEPR theory. So is this theory universally accepted or not? Right. So actually it tried to explain you can say many questions related to shape of molecules, but still it possesses many limitations. Like the limitation 1 is that it actually do not give any information about the shape of the transition metal compounds. It doesn't give the shape about the transition metal compounds. Likewise, it doesn't give any info related to the the shape of the the isoelectronic species, right? And it doesn't explain any you can say the properties of the molecule, whether it is diamagnetic or you can say a magnetic character or a bond order or a bond length. Nothing. It doesn't take into consideration all that. So actually this theory you can say was not based on the quantum theory, and we know that quantum mechanics is the mechanics which is accepted all over, right? So we need to have a theory where we need to find all those unanswered questions. So that is why we are going to start with another theory, that is the last theory which is you can say universally accepted, that is the valence bond and the molecular orbital theory, just based on the quantum mechanics. So just look at the board carefully.